let's look at this question. It says write down the following in the form A plus BI. It means it's not in that form. We have to write it in that form. And then we have to state what is the imaginary part and what is the real part, what is the imaginary part, and what is this conjugate. So by looking at this, this is where conjugates are helpful. I'm going to multiply this fraction by the conjugate of the denominator. So I have 2 plus I and 2 plus I. And then all that I will do, guys, is I will just bring in the brackets so it's easier for me to multiply. Okay, so if I look at this, I will just have this times this will give me 6, and 3 times I will give me 3i. Then we have 2i times 2, which will give me 4i. And then 2i times I, which will give you 2i squared. At the bottom, guys, we can see this. This will just be 4 minus I squared. Now, we can just collect the like terms. We're going to have 6 plus 3i plus 4i will give you 7i. And then you have the plus 2. Straight away, guys, I'm just going to, because I know that I squared is equal to, I squared is equal to -1, so I'm going to go ahead and just substitute that. And then I will have 4 minus, and I'll substitute -1 there. And we can simplify this, guys. We can see 6 minus 2 will give you positive 4 plus 7i over 4 plus 1 will give you 5. And if we have to write this in the form A plus BI, that means it will be 4 over 5 plus 7 over 5i. Okay, so that means now we'll have its real part will be 4 over 5. Okay, then we have its imaginary part. Now, its imaginary part will be of z will be 7 over 5. And then we'll have now its conjugate. And its conjugate will be 4 over 5 minus 7 over 5i. I hope it was quite clear for you. Let's look at this question. This question, again, we are just going to look at what is it's the conjugate of the denominator. And the conjugate of the denominator will be 1 plus 3i and 1 plus 3i. Okay, so if now I then want to work this out by simplifying, I'm basically going to do the same thing I did in this question. So I will have 4 times 1, which will just give me 4, and then 4 times 3i, which will give me 12i. Then 3i times 1 will give me minus 3i, and then negative 3i times by 3i, which will give me negative 9i squared. Right, and then at the bottom, we're going to have 1 minus 9i squared. Then we can see, guys, a difference of 2 squares, as you can see there. That's why it's so easy to do the denominator. Now, all that I'm going to do is collect the like terms. So 12i minus 3i will give me plus 9i. And then I can see here, I can straight away just work this out. Guys, if I have negative 9i squared, this will give me negative 9. If I substitute 1 there, it will be positive 9. So let's just go ahead and write positive 9 over. This also, again, we have negative 9i squared. Okay, that means it's going to be 1 plus 9, because we've seen that this negative 9i squared is just 9. So the answer then will be 4 plus 9, which will give you 13, plus 9i over 10. This means that we can write this as a plus bi will be 13 over 10 plus 9 over 10i, meaning we'll have the real part of z, which will be just 13 over 10, we have the imaginary part of z, which will be 9 over 10. And then we will have its conjugate. And the conjugate of this complex number will be 13 over 10 minus 9 over 10i. And that's it for this question. We're going to move on. Okay, guys, let's look at number 5. For number 5, we see something. The denominators are the same. That means we're allowed to add the numerators. So we will have z is equal to, then the denominator is going to be 2 minus I. And then at the top, we're just going to add. So have 5 plus 2i. Okay. Another thing that I just have to give you a heads up on. For example, let's say that I had 2 plus I over 2 minus I minus 3 plus I over 2 minus I. Guys, if I had to add that, I would have 2 plus I and then minus in brackets, I'll have 3 plus I. That's just a heads up that you have to take note of, because that negative will distribute the 3 and then will distribute the I. Okay, so that's just a by the way. Now, if I want to, because the question then says simplify, so we have to get in that form A plus BI. So that means I have to introduce the conjugate. So let me introduce a conjugate of the denominator, which is going to be 2 plus I over 2 plus I. Straight away, introduce my brackets. Then if I simplify this now, I'm going to go ahead and simplify. At the bottom, it's quite straightforward, difference of 2 squares. So we'll have 4 minus I squared. And then at the top, we'll have 5 times 2, which will give you 10. And then 5 times I, which will give you 5i. And then 2i times 2, which will give you 4i. And then 2i times I, which will give you 2i squared. Right, now let's collect the like terms. We'll have 10 plus 5i plus 4i will give you 9i. Then, guys, we can recall something that we know that I squared can be replaced as negative 1. So we're going to go ahead and just replace it. Put a negative 1 there. Over, okay, say over 4. And that I squared is going to be negative 1. So negative 1 times negative will give you a positive I. A positive 1, sorry. Then the answer now is, if you see here, you have 2 times negative 1, which is negative 2. So if you say 10 minus 2, which will give you 8 plus 9i over 5. Now, this can be written as 8 over 5 plus 9 over 5i. So that means we'll have its conjugate, right? So we'll have its conjugate as 8 over 5 minus 9 over 5i. Then we'll have the real part of z, which is 8 over 5, and then the imaginary part of z, not its conjugate, guys, it will be 9 over 5. Right, let's move on to number 6. For number 6, guys, there's different ways you can think about this, but I'm just going to go ahead and tell you that if we have 2 fractions, we need to add those fractions to simplify before we can do any other thing. And I see that we have 1 minus I and we have 1 plus I. So let's find the lowest common denominator. The lowest common denominator would be 1 minus I and 1 plus I. Okay, so that means for this fraction, I'll have to multiply by 1 plus I over I. So what do I mean by this? This is what I mean. 1 plus I over 1 minus I. For me to have this denominator, this fraction is short of that 1 plus I at the bottom there. So the denominator is short of 1 plus I. That means I'll have to multiply 1 plus I over 1 plus I. And you would say, that's the same as just multiplying with its conjugate. Yes. So 2 over 1 plus I. For me to have this denominator, that means I have to multiply this fraction by 1 minus I over 1 minus I. Then now let me simplify. If I simplify at the top, guys, the bottom, straight away, it's going to be 1 minus I squared. Okay? Also here, the bottom, we're going to have 1 minus I squared. It's quite straightforward, right? At the top there, we can see that we have 1. So let me just go ahead and say this will be 1 plus. This will be 1 times I, which will just be I, and then I times 1, which will just be I, and then I times I, which will then be I squared, right? Here at the top, it's quite straightforward, so we'll just have 2 times 1, which will just be 2, and then 2 times negative I will just be minus 2I. Right, things are coming together, guys. Okay, now we see we have the same denominator, right? So that means we can add the numerator. Okay, the numerators can be added because the denominators are the same. So we'll have 1 plus I. Okay, let me just go ahead and say that was just going to be 2I. So we'll have 2I plus that I squared, guys, I'm going to go ahead and just write it as negative 1 plus. Okay, and then we'll have plus 2 minus 2I. Look at what happens there. That 2I will cancel this guy, and then you have 1 plus 2, which will just be 3. So let's just see. We'll have 1 plus 2, which will just be 3, minus 1, which will just be 2, over 1 minus, oh, I forgot to substitute here. We'll get negative 1. So therefore, you have 2 over 2, which the answer is just 1. We're not done. They asked for what is the real part? Oh, see what I was saying. The real part is 1. What is the imaginary part? The imaginary part, you'd say, okay, the imaginary part is 0. Is just 0. Because this number, guys, can be written as in the form a plus b, bi, then this will just be 1 plus 0i. That's why we're saying the imaginary part is 0 and the real part is 1. Then its conjugate now, its conjugate will be just 1. Because if we were to change this, it will be negative 0i, which will just be 0. So hence, its conjugate is also 1. This was a nice question that was nicely challenging.